Calculus Kids, this is Dr. Callahan for week 8 Thursday, and here are your 3 warm-up block questions. Okay, so last time I saw you guys, we talked about the chain rule. We did several examples with trig chain rules on week 8 Wednesday. You also had an assessment on Math Excel, and it's titled Week 8 Wednesday. Make sure you do the 10 questions. It is multiple choice, and it is due 1 week from Wednesday, so it will be due next Wednesday. I will highly recommend you guys complete this, and again, it is on Math Excel. Keep in mind that in this class, we don't have any tests. We just simply have assessments, and it's every Wednesday. All right, let's go take a look at the breakdown of today. Today, we're going to talk about the derivative trig functions with product, quotient, and chain rule. So we're going to be combining all 3 together. We're going to go over my notes on chain rules and chain rule and chain rules using trig derivatives. I will give you the question and also provide the answer, and you are going to go ahead and try to see if you can show the work to lead the question to the answer. Number 7, we also have my notes on video. So I will give you guys a guided notes in your guided note packet, and then I have a video that goes over some examples from the textbook. All right, let's go ahead and get started then. In class, we will be doing a few questions on quizzes, but given the fact that you guys are online right now, that will not happen, unfortunately. But let's just go over some of the questions that I think most students do miss. So for question number 1, if f of x equals sine parenthesis x squared minus 3, this generally is when the chain happens, what is f prime of x equals? So the derivative of sine is going to be cosine. And remember, this is like kind of like saying sine u. If you're looking for the derivative of sine u, it is going to be a cosine u times u prime. And that's what the chain is. So if I say let u be x squared minus 3, so that's going to be u, then u prime is just 2x. So then if I look at the f prime of x formula, which is equal to cosine u, well, u is going to be x squared minus 3 times u prime, which is 2x. And that would be A. Then the second type of question we went over involved a square root, okay? So again, this right here is where the chain happens for u. So then looking at this, I'm going to rewrite it because I don't like the fact that there's a square root. So you know this is a square root, so x minus 2 is really going to be, remember, it's going to be the power over the root, so 3 over 2, because the power is 3 and the root is 2. So then what we're going to do is we're going to go ahead and apply the power rule and then the chain rule. In the take the 3 over 2, bring it down. So you have a 3 over 2, and by the way, this is f prime of x now. X minus 2 minus, make sure you subtract a 2 over 2, which is going to give you a 1/2, times, and you have the time the chain, which is the u right here. So u prime is just going to give you 1. So then looking at this right here, let's go ahead and simplify this a little bit. And you will have 3 square root x minus 2 over 2. Times 1. Let's see. All right, let's go ahead and move on to today's stuff. So if you take a look at your notes today on week 8, Thursday, you will be able to see that we have this sheet right here. Here I have 1, 2, 3, 4, 5, 6, 7 different questions and also 7 different answers. So I want you to go ahead and practice finding the derivative with product rule, chain rule, quotient rule, and also the derivative of trig functions. And see if you're able to get to that. And as always, you have the link right here to check your answers. But then again, I also provide the answers for you guys. So pause the video and start practicing with some of these. All right, let's go ahead and take a look at some of these. All right, let's go ahead and take a look at the first one. So here's y, it's secant 3x over 2x squared, and it's asking to derive. So y prime is going to be using the quotient rule, which is f prime times g minus f times g prime over g squared. Now, you know you have 5 components. F is going to be secant 3x. F prime, the derivative secant, is going to give you a secant tangent. So secant 3x, tangent 3x, times, don't forget your 3, because the derivative of 3x is going to be 3. So you have a 3 right there. And next, what we have here is going to be g, which is going to be the denominator, 2x to the 5th, g prime, which is 10x, and g squared, which is 2x to the 5th squared. That's going to give me a 4x to the 10th. So let's go ahead and do this. F prime times g. So here is f prime times g. Well, 3 times a 2x to the 5th is going to give me a 6x to the 5th, secant 3x, tangent 3x, minus f times g prime. So that's secant 3x times 10x, which is going to be a 10x. Actually, I can just go ahead and do a, yep, actually it's 10x secant 3x. All the way over g squared, which is going to be 4x to the 10th. Oh, one thing I forgot is the 4th power. Sorry about that. 10x to the 4th, because when we bring down the 5, we get a minus 1. Forgot about that. All right, so then looking at this part here, I noticed that what I share here in the top and bottom is x and x and x. They have different levels of exponents, but I can go ahead and perhaps cancel a few of them. So I can actually factor out x to the 4th out from the top and bottom. So 6x, secant 3x, tangent 3x, minus 10x to the 6th, secant 3x. And because you have x to the 4th on top, and this becomes 4x to the 4 times x to the 6, I can cancel that. And that is what I'm left with. But in addition to that, I also realized that, guess what? There's a 6 and a 10, which means I can take out a 2, which inadvertently would change that 6 into a 3, and this 10 into a 5. And I can go ahead and do a 2 times 2, which is 4, and cancel that 2 as well. So then what remains here is going to be and actually what I can do, sorry, just noticed this as well, is you can take out a secant 3x right here. So I will have, there's nothing on the outside anymore, that canceled. So I have a secant 3x, 3x tangent 3x, that remains in the first part of the binomial, minus 5x to the 6 divided by 2x to the 6th power, which is exactly what you have right there. I just noticed something here. Hold on a second. I don't know why I went ahead and put a 6 right here. That's crazy because I just factored that out. So there should not be any excess. I'm sorry about that. So just get rid of that. Sorry. All right, let's take a look at the next example. With this one, you will have to go ahead and rewrite this. So f of x is equal to x to the 5th times x to the 4th minus 1 to the 1/3. Now looking at this, you will probably have to go ahead and use the product rule. And the product rule is going to be f prime times g plus f times g prime. I'm going to identify my f as x to the 5th. So f prime is 5x to the 4th power. G is going to be x to the 4th minus 1 to the 1/3. So g prime, go ahead and apply the power rule and then the chain rule is 1/3 x to the 4th minus 1. But when you subtract a 3 over 3, it's a negative 2/3 times the chain of x to the 4th minus 1, which is just 4x to the 3rd. And already as I'm looking at this, I'm like, this looks really ugly. So I want to rewrite this with the 4x to the 3rd over 3. And then I want to move the x to the 4th minus 1 to a positive 2/3 power. So then from there, let's apply the theorem then. So f prime of x is going to be f prime times g, so that's 5x to the 4th times, what just happened here? Times g. Okay, there we go. Sorry about that. Oh, for crying out loud, stop it. So times g right here. So that is going to give you a 5x to the 4th times x to the 4th minus 1 to the 1/3 plus, second part is f times g prime, which is this ugly piece right here. And I shouldn't say ugly, that's not a very nice word. Everything is beautiful in math. 4/3 x to the 3rd, and then the bottom x to the 4th minus 1 to the 2/3. And I don't like having a parenthesis with a parenthesis, so I'm going to change it to a bracket. Well, we are not anywhere close to f prime of what the actual answer is. And this is kind of a thing, is that, yeah, even though you apply the rule properly, if you can't find the answer of what you have here in the multiple choice, that's kind of a problem. So then looking at this, I'm going to ask myself, what can I do to go ahead and maybe bring those two fractions together? And I'm going to say that because you have these two numbers here, and they're actually together in the numerator, you can put that as a 4x to the 8th over 3 parentheses x to the 4th minus 1 to the 2/3. Now your denominator is this part on the bottom right here. So I would probably have to multiply my first fraction by that. So I will have to multiply, see the bracket, 2 times x to the 4th minus 1 to the 2/3, and 2 times x to the 4th minus 1 to the 2/3. So now that I have the common denominator, which is 3, not 2, sorry, that's a 3. Come on, Kelly, I can get with that. 3. 3x to the 4th minus 1 to the 2/3. I can now focus on my numerator here, which is just this part right here, and perhaps simplify that. It actually is not as ugly as what you might think it would be. So 5 times the 3 is going to give me a 15. And then I have x to the 4th, that doesn't change, times, do you see how this x to the 4th minus 1 is a 1/3 power and this is a 2/3 power? Well, 1/3 plus 2/3 is just going to give me 1. So it's just x to the 4th minus 1 to the 1 power. So that actually worked out pretty nicely. But then do not forget your exponent, or excuse me, your numerator for the second part of your fraction, which is the 4x to the 8th power. Phew, well, that looks a lot better than before, that's for sure. So now what I'm going to do is let's go ahead and take a look how I can get this to this right here, because the denominator matches, but how do I get the numerator? Well, I will probably have to go ahead and distribute this, 15x to the 4th. So I have 15x to the 8th minus 15x to the 4th plus 4x to the 8th. Combine my like terms, I have a 19x to the 8th minus 15x to the 4th. And I know I can factor out an x to the 4th, which will leave me with 19x to the 4th minus 15. And don't forget your denominator, so that over x to the 4th minus 1 to the 2/3 power. And oh my goodness, they match. All right, you guys, I'm gonna have you guys practice the remaining parts of this by yourself and see if you can go ahead and practice to get that. When you're done with that, take a look at this page, which is also in your guided notes. So with this one, you are going to have your second set of flashcards. I know you're like, but didn't we just get one? You did, but this is a different one. So you're going to go ahead and cut them out, and you're going to tell me what are the answers of these derivatives on the back of the cards. And these are a little bit different because even though they do have some regular trig derivatives, but most importantly, they also have the logs, the ln and the e's, which we talked about yesterday as well. And also the a to the x's. So make sure you guys go ahead and do that and keep them in an envelope and memorize them. If you're like, oh, you know what, I don't know some of them, well, that's okay, because in your guided note, you also have this page, which actually shows you all of the trig functions of how you can write and rewrite them. All right, so let's go ahead and move on to the next piece. So turn over to this guided note right here. This is kind of review of product rule and quotient rule with higher order derivatives. These are from your textbook. You can go ahead and try to work on these by yourself first. If you do get stuck, however, take a look of this link right here, and that will take you to the video that explains all of these examples step by step. All right, you guys, I hope you guys have an awesome day. And as always, stay safe and healthy. And I will see you guys next time. Take care.